Welcome to Quantum, the channel that unravels the mysteries of creation and unveils the inner workings of the world around us. Today, we're diving deep into the fascinating realm of engineering. In this episode, we'll explore the intricate process of how submarines are made, from design to construction. Get ready to embark on a journey of discovery as we unveil the secrets behind these marvels of underwater technology. In their dreams, Aristotle and Alexander the Great envisioned a world in which people worked underwater. We're going to take a more in-depth look into the realm of submarine building and learn about the process by which these engineering marvels are brought to life now that their ideal has been turned into a reality. The process of designing and planning the specifications of a submarine is the initial step in the construction of a submarine. This involves selecting the dimensions, shape, propulsion system, weaponry, and other characteristics of the submarine according to the purpose for which it'll be implemented. In the event that the design and planning stages have been successfully implemented, the next step is to acquire the raw materials. There are many different materials that are utilized in the construction of submarines. Some of these materials include high-strength steel, aluminum, titanium, copper, and sophisticated composites. These raw materials are obtained through mining and extraction procedures, and then they are refined in order to get the material forms that are needed. Following that, manufacturers and suppliers who specialize in the industry supply them. The procedure may finally be put in motion once the supplies have arrived at the construction site, and the process can begin with the hull, which is of the utmost importance. High-strength steel or sophisticated composite materials are often used in the construction of the submarine's hull, which serves as the primary body of the vessel. To begin, acetylene torches are used to cut the steel plates into the specifications that are wanted. Afterwards, rollers of industrial grade are used to bend them into the desired shape. A wooden template that depicts the shape of the hull is then used to guide the placement of the plates around the template. In order to create an inner hull, the plates are welded together after they've been positioned. This procedure is repeated for the outer hull, and spaces are left between the hulls to accommodate the ballast tanks, which are essential components of a submarine. Having the ability to alter their buoyancy, submarines are able to sink or rise in the water depending on their environment. In the past, this was accomplished with the assistance of air and water pumps. However, a scientist by the name of Nathaniel Simmons did something that completely changed the game. As a result of his work, contemporary submarines are equipped with ballast tanks that are mechanically operated and are situated between the hulls. As a result of filling these tanks with water, the submarine becomes heavier and sinks. In order to surface, the submarine pumps out the water from the ballast tanks, which reduces its overall weight and increases its buoyancy. The use of construction materials like high-strength steel or contemporary composites during the tank's fabrication ensures the tank's durability and watertight integrity. The process of welding or joining the steel plates or composite sections together to create the tanks follows their shaping and production in accordance with the design specifications. Both the inside and exterior surfaces of the tanks are coated with protective coatings in order to prevent corrosion and ensure that the tanks will last for a long time. The tanks are attached to the surrounding components and are coupled to them in a secure manner. They're also seamlessly integrated into the structure of the submarine's hull. The crew is able to precisely manage the buoyancy of the tanks by installing control systems that include valves, pumps, and piping. These systems allow the crew to fill or empty the tanks. As soon as the exterior shell is finished being constructed, the personnel will start working on the inside areas of the submarines. Different compartments in submarines are designed to house crew members, numerous pieces of equipment, and a variety of facilities. There are living quarters, control rooms, engine rooms, torpedo rooms, and other compartments that are included in these compartments. It's necessary to incorporate life support equipment into the interior compartments of the submarine in order to provide the crew with the ability to function underwater. In order to provide breathable air, clean water, and effective waste management, these systems are very necessary. The requirements for the size of the crew and the duration of the mission are taken into consideration throughout the design process. Components like air purification units, water desalination systems, and waste treatment systems are purchased from manufacturers and incorporated into the compartments of the submarine in order to make the submarine operational. Within the hull, there are a number of intricate systems that need to be incorporated. This includes the propulsion system, engines, propellers, electric motors, navigation systems, communication systems, weapon systems, sonar, and periscopes. Additionally, this contains an electric motor. When it comes to submarines, the propulsion systems are carefully researched and chosen depending on a variety of variables, including the intended usage, range, and speed, among others. Diesel engines provide power to the submarine and charge the batteries when it's operating on the surface. After the submarine has been submerged, it will convert to electric propulsion, which will use the electrical energy that's been stored in the batteries. Initially, each of these components is built independently and subsequently, they are incorporated into the hull of the submarine. Electricity is transferred from the engines to the various components through the establishment of connections that are both mechanical and electrical in nature. After that, submarines are outfitted with navigation devices such as sonar, gyroscopes, and global positioning systems or GPS in order to ascertain their position, track vessels, and steer clear of obstructions. After that, they are connected to power and data networks, and calibration is performed to guarantee that the capabilities and readings are accurate, allowing for precision navigation and knowledge of the surrounding environment. Before a submarine is put into service, it's put through a series of rigorous tests and trials to verify that it continues to function properly and remain safe. This encompasses testing for leaks, testing for pressure, testing for sea trials, and evaluating a variety of different systems. The results of these tests indicate whether there are many problems or areas that need to be improved. It's possible that the total cost of the process might range anywhere from $80,000 to $80 million, depending on the specifications of the submarine and its size. In the event that the submarine in question is a nuclear submarine, the price tag may increase to a maximum of $3 billion. That wraps up today's episode of Quantum, where we delved into the incredible world of submarine construction. If you enjoyed this exploration into the making of submarines, don't forget to hit the like button, subscribe for more captivating content, and ring that notification bell to stay updated on our latest episodes. Join us next time as we continue to unravel the tapestry of creation and showcase how everything is made and how everything works on Quantum. Thanks for tuning in, and until next time, keep questioning, keep learning, and keep exploring the wonders of our quantum world. Please let us know in the comments what you think should be the subject of our future video.